first question here is from force, other mechanics. Question reads, which of the following quantities is not an example of force? Option A say mass, B say tension, C weight, and D friction. So we are going to analyze each option. Now, option A, say mass. Mass is the component of matter. That means the constituent of a matter is what matter is made up of. So, B, tension. Tension is a force that tends to extend an object. And C, weight. Weight is a force that pulls an object to the center of the earth. And D, friction. Friction is a force that opposes the motion of two objects moving relative to each other. So from the options, you can see the only one that is not a force here is mass, which is the quantity of matter a body contains. So the answer is mass. So let's move on to the next one. Question 2. Now, question 2 is from transformer. It said the reason for laminating the soft iron coil of a transformer is to. Now, in transformers, there's what we call losses, energy loss in transformer. Now, other transformer, we have what we call practical transformers and ideal transformer. Now, for an ideal transformer, we assume that there is no loss. But for practical transformer, we have losses. And such losses, we have what we call the eddy current loss, you have the magnetic flux leakage, you have what we call heat loss, and what we call hysteresis loss. But this question says, which of these is the reason for laminating the soft iron coil of a transformer? We are going to analyze each option. The first one is A, to reduce eddy current. Now, eddy current is a loss in transformer that results as a result of what? The varying of the flux from the primary coil or from the soft iron coil. Now, how do you reduce eddy current? You reduce eddy current by laminating the coil. So eddy current reduces the efficiency of a transformer because it comes in form of heat loss. So because it reduces the efficiency of a transformer, you cut away the varying flux from the primary coil, from not entering the secondary coil. So in doing that, you have to laminate the coil. So lamination of the coil reduces eddy current loss in transformer. Then B, reduce the magnetic flux. No, magnetic flux leakage can only be reduced by using what we call efficient coil design. You design the coil very well so that leakage will not occur. And increase the magnetic flux, it doesn't. It does not increase the magnetic flux. And D, it reduces its efficiency. Fine. Eddy current is what is responsible for the reduction of efficiency in transformer. So the right answer here is eddy current. It reduces eddy current loss. Take note, we laminate soft iron coil in transformer to reduce what? Eddy current. Now, next question is from cell, electrochemical cells. Now, it said formation of hydrogen bubbles at the copper plate of a primary cell is called dash. Now, the first one is what we call polarization. The second one is what we call back EMF. The third option is electrolysis. And the fourth option is local action. So we are going to look at the options one after the other. Now, in cells, in physics, there's what we call defects of cells. An example of such defects, we have what we call polarization and local action. So we are going to analyze polarization. What is polarization? Polarization is just the defect that occurs as a result of the chemical reaction that takes place in a cell. Now, this results to the gathering of hydrogen bubbles at one of the electrodes of the transformer. Now, how do you reduce this? You reduce this by using what we call a depolarizer. A depolarizer. An example of depolarizer is what we call manganese 4OZ. Now, polarization is what is defined in the question. So, formation of hydrogen bubbles at the copper plate of a transistor is called polarization. Now, the next one, B, back EMF. Back EMF is an EMF that opposes the current. That means when a current is flowing, there is an induced EMF, you have what we call induced current. It flows in such a way that it opposes the current producing it. So back EMF is not the option. Now, electrolysis. Electrolysis is the chemical decomposition of a compound into its component ion, so which is of local action. Local action is a defect in cell that results as the result of what? Pure electrodes. Pure electrodes. So how do you use reduce local action in cell? What you do is that you amalgamate the cell. You use mercury to reduce local action. So from the question, the best option or the correct option is option A, which is what? Polarization. Next. Now, next question is from heat energy. Which of the following factors does not affect the rate of evaporation of a liquid? The first one is temperature, the volume, the wind, and surface area. As we'll be doing, we are going to look at each option, analyze each option. Temperature. Now, the temperature of an environment or the temperature around a liquid affects the rate of evaporation. It means if the temperature increases, the rate of evaporation will increase. Now, if the temperature reduces, the rate of evaporation will also what? Reduce. So temperature is a factor that affects the rate of evaporation of a liquid. The next option is what we call a volume. Volume does not have effects. How? Whether the liquid is small or the liquid is big or large, the volume of the liquid does not have effect on the rate of evaporation. Wind, yes. Evaporation occurs at the surface of a liquid. So if the wind blows across the surface of a liquid, definitely the rate of evaporation will increase. The next one is surface area. Yes, the amount of the area exposed or the amount of the area of the liquid exposed to the surface or to the atmosphere determines the amount of the particles that will be what? Evaporated from the surface. So temperature affects the rate of evaporation, volume does not have an effect, wind has an effect, and surface area have an effect. So the right option here is option B, which is what? Volume. Next. Now, next one said the opening in the eye through which light passes through the retina is called the dash. Now, the pupil is the part of the eye that allows light to enter the eye. So, pupil allows light to go into the light. Cornea, yes, is part, but is not strictly responsible for the entry of light into the eye. Iris covers the pupil at the cornea. So iris does not play that role as the pupil. So the pupil plays the role of light entering the eyes through to the retina, the optic nerve. This is the part of the eye that connects the central nervous system to connect the eye to the central nervous system. It is the major area that is very, very sensitive to the eye. So it transmits signals to the brain. So the best option here is option A, which is what? Pupil. Next. Now, its resistor made up of semiconductor is known as dash. Now we have option A, thermometer, thermostat, thermistor, and thermopile. Now, the first option is thermometer. A thermometer is a substance that is used to measure the temperature of a liquid. We have different types of thermometer. So thermometer is generic, it's not the particular type. Now the next one is a thermostat. A thermostat is a regulator, it's a temperature regulator. Now it's not made up of a semiconductor. Now a thermistor. A thermistor is a semiconductor that regulates what? Temperature. So thermistor is a semiconductor that regulates temperature, while a thermopile is not part of the option. So the correct option here is what? A thermistor. Next question. We have electric motor converts dash. So we are in question 7 now under electromagnetism. Now we have some devices in physics. That's what we call a dynamo. A dynamo is any device that can convert electrical energy to mechanical energy or mechanical energy to electrical energy. And we have two examples of a dynamo. We have what we call a motor and a generator. So a motor converts electrical energy to mechanical energy, while a generator converts a mechanical to electrical. So the option A said electrical energy to chemical energy, which is not true. Next said kinetic energy to potential energy, which is not true. C, electrical energy to mechanical energy, which is the right option. And C, electrical energy to heat energy, which is not true. So the right option here is what? Electrical energy to mechanical energy, because it's in what? A motor. Next. Now, which of the following statements about the molecules of solid and liquid is correct? They both have weak attraction. B, have wide separation. C, exhibit random motion. And D, exhibit vibratory motion. Let's take one after the other. Now, have weak attraction. The molecules of solid, they don't have weak attraction. They have what we call strong molecular force between the molecules. That is why they only vibrate about their main position. The liquid, the force of attraction between the molecules of liquid and solid, the solid's force of attraction is higher, while the liquid, they have moderate attraction, but not as weak as that of what you have in gas. B, have a wide separation, which is not true. The molecules of solid are firmly bound together, so there is not much distance between the molecules of solid. The same place to liquid. Next one, exhibit random motion. No, because the molecules of solid, they are fixed. They only vibrate about their main position, while solid can move about. Remember, the question says, which of these is similar? What do they have in common? The last option said they exhibit vibratory motion. Yes, the molecules of solid vibrate about their main position, and also the liquid vibrates about their main position. For liquid, they do that when they undergo rotational motion and translational motion. So the right option here is what? They exhibit what we call vibratory motion. Next. Now, the distance between a node and its adjacent antinode of a transverse wave is equal to that. Now, we have a wave. We have what we call a node. We have what we call antinode. We have what we call a node. Now, what is a node? A node is a point in a stationary wave or a transverse wave where we call the molecules of the wave have what we call minimum vibration. Now, while an antinode is a point in a stationary wave, while the molecules exhibit what we call the maximum vibration. Now, the distance between a node and antinode is 1/4 of the wavelength, while the distance between a node and a node is 1/2, which we have by adding 1/2 plus 1/4, sorry, that will give me 2/4, that will give me 1/2 of the wavelength. So it means that if I'm talking about a node and antinode, distance is 1/4. So the length is wavelength, 1/4 of the wavelength. So the answer is what? D, which is quarter of the wavelength. Next. Now, which of the following graph below illustrate the current variation of gravitational force between two objects and the distance between their centers? Fine. Now, under gravitational field, according to Newton's laws of gravitation, states that the force of attraction is inversely proportional to the square root of the distance between masses. So we are going to take a sample. Let's see if we can get a graph that looks like what we have. So let's assume a situation where we have the distance between two masses. Let's say these masses are, let's say M1 and M2. So my R will take its value from 1, 2, 3, and 4. So if I have my force, so when my R is 1, my force will be 1. When my R is 2, my force will be 1 over 4. When my R is 3, my force will be 1 over 9. When my R is 4, my force will be 1 over 16. Now, if I'm to draw a graph of what I have here, I'm going to have something like this. Let's say this is my force. Let's say this is 0.1. Let's say I have 1 here. So I have my 1, 2, 3, 4. So I have 0.1. I have 1 here. I have 0.1. Let's say here is 0.5. So I have maybe 0.3 here and so on till I get to 1. So at 1, my force is 1. So this is the distance. At 2, 0.25. So somewhere here, say somewhere here. At 3, 1.9. Somewhere here, 1 over 9, sorry. So at 4, so 0.0625, I'm going to have, let me say somewhere here. So if I draw a curve like this, just trying to draw. So the only curve that looks like the curve I just drew is option C. So option C looks like the curve I just drew. So if you plot a graph of F and R and distance of separation between masses, the curve you have is like option C. That is that. Okay. Next. So which of the following action will increase the capacitance of a parallel plate capacitor? Nice. Now, in static electricity, we know that a capacitor can store charge. Now, the capacitor, the ability of a capacitor to store charge is what we call the capacitance of the capacitor, which is C. Now, the capacitance of a capacitor is directly proportional to the area and inversely to the distance of separation. Now, if I remove this sign, I'm going to have A over D. Now, how does this one affect the capacitance of the capacitor? It means that if the area increases, the capacitance will increase. Now, if the distance increases, the capacitance will reduce. Now, if the distance reduces, the capacitance will increase. That means, take note, the capacitance increases when the area increases. Capacitance increases when the distance of separation reduces. Now, what does this E naught stand for? The E naught stands for what we call permittivity or free space. What does it mean? It means what is the nature of the insulator around there. So it means that if I have an insulating material, the insulating material will increase the capacitance of the capacitor. That means the presence of a dielectric substance between the plates of a capacitor increases the capacitance of a capacitor. So let's go back to the option. The first one said decreasing the distance between the plates, which is correct from what I just explained. If the distance decreases, the capacitance will increase. Now, increasing the distance between the plates, no. If you increase the distance between the plates, the capacitance will reduce. So this one is off, it's not there. Now, increase the area of the plates. Yes. If the area increases, the capacitance will what? Increase. Now, avoiding the use of dielectric between the plates, no. If you allow a dielectric material, the capacitance of the capacitor will also increase. So from what we've done here, the correct options are 1 and 3. So option A is the right answer. Next. A metallic sphere is heated from 27 degrees Celsius to 200 degrees Celsius without change of states. Which of the following changes would have resulted from the heating? Now, note, this is a metallic sphere. Now, if a metal is heated, there will be an expansion. So if it expands, it means the volume increases. So effects of temperature on any metallic substance, increase in temperature will increase the volume. That means if the volume of the substance increases because the temperature increases, it also means that the density of that substance will decrease. Because if you increase the temperature of a solid, the density of that substance will what? Reduce. So volume increases and density decreases. So the right option here is C. Next. The acceleration of a moving object can be determined from, now, you have distance time graph, or the slope of a distance time graph, area under its distance time graph, slope of its velocity time graph, and area under velocity time graph. Now let's take option A. Now if I plot a graph of distance against time, and I draw a graph, the slope of this, that is change in D over change in T, will give me distance over time. So distance over time is what we call speed. So it's not acceleration. So this one is off. Area under distance time graph. So area under distance time graph will give you the distance, or will give you the distance. So the area under it is not the answer. The next one is slope of velocity time graph. So if I do slope of V over T, if I look for the slope here, the slope of this will give me change in V over change in T. So which will give me what? Acceleration. So this one is off. Now area under its velocity time graph. So the area here will also give you what we call distance or displacement. Take note, the area under the graph will not give you acceleration. Is the slope of the graph of velocity against time that will give you acceleration. So the right option here is what we call is option C. Next. A student wishes to measure the potential difference across a resistor R. She has a galvanometer G and some connecting wires. What else does she need? Now, this is a case of converting a galvanometer to a voltmeter. Now, a galvanometer is an instrument that measures small amounts of current or potential difference. Now, since it does not have, the student does not have a voltmeter, so what he's trying to do, she wants to connect or convert a galv to a voltmeter. So how do you do this? Now, in connecting a galv to a voltmeter, you connect a resistor in series with the galvanometer. So this resistor, how is it? Now, in doing this, this resistor would be of a high resistance. So when converting a galvanometer to a voltmeter, a resistor of high resistance is connected in series with the galvanometer. So that resistor is what we call a multiplier. The resistor is what we call a multiplier. So if you want to convert a galvanometer to a voltmeter, connect a resistor of high resistance in series with the galvanometer to give you that voltmeter. So the answer here is high value resistance. A says a high value resistance connected in parallel. No. Now if you are converting a galv to a voltmeter, what you do is that you connect a high value resistors in series, not in parallel. Now, B, low value resistor connected in parallel, which is not true, must be high value, but it must be connected in what? Series, not in. So the next one, low value resistor connected in series with the galvanometer. No. The last option is high value resistor connected in series with the galvanometer, which is the what? Answer, option D. Now, I want you to know that you can also convert a galvanometer to ammeter. In doing that, you connect a low resistor in parallel with the galvanometer, and that resistor is what we call a shunt resistor. So take note of this. In converting a galv to voltmeter, a high value resistor is connected in series with the galvanometer. While converting a galv to ammeter, a low value resistor, which is known as a shunt, is connected in parallel to the galvanometer. So the right option here is what? Option what? D. Next. Now, machine, the handle of a screw jack is 35 centimeters long and the pitch of the screw is 0.5 cm. What force must be applied at the end of the handle to lift the load of 2,000 Newton if the efficiency of the machine is 30? Now, this from machines, I want to look at this is a screw jack or a screw. Now, the VR of a screw is giving us 2 pi R over pitch. Now, the R there is what we call the length of the tummy bar or the handle, the length of the tummy bar. So in this case, your R is 35. So your P, my pinch, is 0.5. Now, if I substitute, I'm going to have VR is equals to 2 times 22 over 7 times my R is 35 over 35 divided by 0.5. Now, if I do this, I'm going to have, use your calculator, I'm going to have 2 times 22, 35 that will give me times 70 over 7. So this one will go, this one will give me 10. So that will give me 44 times 10. That will give me 440. That is the velocity ratio. Now, if my VR is 440, I know that from machines, the efficiency of a machine is given as MA over VR times 100%. So if that be the case, I'm going to get my mechanical advantage. So I'm going to use, my efficiency is 30% is equals to my MA over what? VR, which is 440 times 100. So if I do this, I'm going to have 0.3 is equals to MA over 440. So if I multiply 0.3 by 440, I'm going to have 132 is equals to my mechanical advantage. So my MA is 132. I also know that my MA is load over effort because they asked me what force must be applied. That means the effort. So my effort is load over MA, which will give me my load is 2,000 divided by 132. So 2,000 divided by 132, that will give me 15.15 Newton. So approximately 15.2 Newton. So my ops is what? C, 15.2 Newton. Next. It said the inductive reactance in a circuit of frequency 100 Hz is 1 ohm. Calculate the inductance of the inductor. Now in AC circuits, we have what we call an inductor. We have what we call a capacitor. So if you have an AC circuit that is made up of an inductor alone, the opposition it offers is given as inductive reactance. Now, the inductive reactance of a circuit is given as XL, which is 2 pi FL. Now, F is the frequency and L is the inductance. Now, my XL from the question is given as 1 ohms. My frequency is given as 100 hertz. And my pi is given as 3.14. So if I'm to look for the inductance L, if I make XL the formula, I'm going to have XL over 2 pi what? F. So my XL is 1 over 2 times 3.14 times the frequency, which is 100. So if I do that, I'm going to have this. I'm going to have 1 over 2 times 3.14 times 100. That will give me 628. So if I look for the inverse of 628, 1 divided by 628, that will give me 1.59 times 10 raised to the power minus 3 Henry. The unit of inductance is Henry. So 1.59 times 10 raised to the power minus 3 Henry. So the correct option here is what? Option B. Option B. Please take note, this is how you solve for inductance in an AC circuit. Now, if in case you have a capacitance, you have XC. So XC is given as in case you want to solve. XC is equals to 1 over 2 pi what? FC. So you can use this one to get whatever you want to look for. Next. So the distance above, the diagram above illustrates the velocity time graph of a body, calculates the distance covered by the body during the motion. Now, the distance here, they're asking us to look for the area under the graph. Now, we are going to start from here. We're going to look for the area of this shape. Now, I'm going to divide this one into 2. We look for the area of this one. Let me call this one A, B, and C. Now, if we do this, we are going to have something like this. Now, the first thing we do here is we are going to look for the area of A. Now, A is a rectangle, so the area of A is length times breadth. That will give me 4 times 4. That will give me 16 meters. Area of B is a triangle, which is half base times height. Now, the base of B is, 12 minus 4, which is 8. The height is 10 minus 4. 10 minus 4, which is 6. Now, if I do that, I'm going to have 1 all over 2 times 8 times 6. That will give me 4 times 6. That will give me 24. Now, we are going to look for the area of C. So, area of C is a rectangle, which is length times breadth. That will give me 8 times 4, 32. Now, 32 plus, and now look for the total area now, is equals to A, area of A plus B plus C. That will give me 16 plus 24 plus 32. See, that will give me 72 meters. So the answer here is what? Option C, 72 meters. Next. Now, an atom that emits an alpha particle may become a conductor of a different element. Let's look at it. Now, when an atom emits, let's say atom X. Let's say it's P, the atomic mass is P, atomic number is N. Now, it emits an alpha particle, form atom Y. Y will now be P minus 4 and N minus 2. So what it means in essence is that alpha particle is an helium nuclei, which is 4, 2. The atomic mass will reduce by 4, while the mass number will reduce. Atomic mass will reduce by 4, that means the mass number will reduce by 4. Now the atomic number will reduce by 2. And we know, and I want you to know that the atomic number will tell you the type of atom or element you have. So if the atomic number changes, it means the atom is a different element. So it means that it will give birth to a different element always. So whenever there is an alpha emission, the element you will have as a result will be a different element. We call it a daughter element. So always, there's always a daughter element. So here, option A may become a daughter of a different element, become a different isotope of the elements. No. Become a daughter with increased mass. No. The mass will not increase. The mass will what? Will reduce. D. Becomes a daughter of a different element. Always. Yes, it's always. Not maybe. It's always. So whenever there is a change in atomic number, the mass number differs or reduced by 4, and the atomic number reduces by 2. As a result of that, a different element is always what? Formed. Take note. Next. Now, which of the following units is equivalent to the units of electric current? Now, we know that current is the amount of electric charge passing through an area. So it means that I is equals to Q over T. So amount of electric charge passing through an area per unit time. So if Q is equals to IT, it means my current, my Q is measured in coulombs, and my time is measured in seconds. So the answer, the other unit of current is what? Coulombs per seconds, which is A. Also known as what? Amperes. So the right option here is what? A. B is not here, watts. Watt is for power. Joules per seconds is also energy over time, which is also what? Power. And coulombs is only for electric charge. Please take note of that. Next. A ball is swung in another circle of center O with a constant speed. What is the direction of its acceleration? There is what we call centripetal acceleration. The centripetal acceleration of a body undergoing circular motion is always directed towards the center of a circle. So from this, it's clear. It's towards the center of a circle. Away from O, no. It's always inside. Along the circumference, no. And C, towards O, correct. So the right option here is option C. And do you say along the target? No. The centripetal acceleration is always towards the center of a cycle.